Hi geometry team, welcome to Unit 4, Day 3. We're continuing to work on triangles, and now we're going to focus on special segments inside of triangles that can do certain things for us. So let's jump right into it. We have here a generic triangle, and in it I am focusing on this segment that is running from a vertex and down to this side of the triangle, and you will notice that these two sides of that triangle are the same length. Well, if you have a segment that divides a side into two congruent lengths, it must be going through the midpoint. That makes it a bisector, okay? And so if you have a segment that goes from a vertex and bisects the other side, this is called a median. It's the median because it goes through the middle of a side, okay? And so we've got our median here. There are three medians in this triangle, starting at this vertex, going to this middle, starting at this vertex, going to this middle, and starting at this vertex, going to this middle. Okay, so we've got three different medians in here. You'll notice that these three all meet up at the same point, which is a little bit unexpected. You'd think one might get off, but no, they always meet at the same point in the middle called the point of concurrency. And this point of concurrency gets a fancy name because this is math and we get everything fancy names. And this is called the centroid. So these medians that we have created that go through these midpoints meet at the centroid. So lots of different words that sound like medium, center, and middle. This centroid here is always 2/3 the distance from this vertex to the opposite side. This is 2/3 the way. You're not going to have to know that, but I thought it'd be a fun piece of information to put in here. Another fun fact about this centroid, this is the balance point of the triangle. So if you were to take this thing and lay it flat and balance it, this would be its center of gravity. So for those of you who are interested in science and have heard of center of gravity, now you know in a triangle it's at this centroid. Okay? For our medians, if you're looking at a picture of a triangle and you want to know if what you're looking at is a median, you think, well, medians cut a side in half. So you're going to be looking for congruent pieces on each side of the triangle. So if you see, wow, this segment cuts it on each side and goes through this vertex over here, then I know that this must be a median of the triangle. Conversely, if you know something is the median, you should know to mark these two sides of that side as being congruent because it'll always be going through that midpoint. Cool. So medians start at the vertex, go to a midpoint. Let's try something new. Here we have an altitude. And for this one, I forgot to set this all up to be clickable, so you get to see it all ahead of time. An altitude is going to be a segment that goes from a vertex, but this time, instead of always going to the middle, it's always going to go and create a right angle with its opposite side. And so it's coming from a vertex to a right angle. It might be off to the side, might be over here. Depending on your triangle, if you have a nice obtuse triangle, you might even have an altitude that is perpendicular to this side, but isn't perpendicular to it unless you come way out here on this exterior angle. Okay, so altitudes, the main thing you're looking for is that they are perpendicular. They make right angles. Okay, so here we've got an altitude coming from this vertex to make a right angle. This one comes from this top vertex to make a right angle, and this one comes over here. Okay, notice once again, all of these altitudes are meeting at a point in the center, all three in the same spot. That's your point of concurrency. And for the altitude, your point of concurrency is called the orthocenter. Where they get that name, I can't remember what ortho means. But we do know that this orthocenter can be inside, outside, or even on the edge of a triangle if you happen to have a right triangle. And so, again, you don't necessarily have to know that, but just be aware that there's some fun things that this orthocenter can do for us, okay? And so if you're looking at a triangle and you want to know if what you have is an altitude, the thing you're going to be looking for is a line that starts at a vertex and makes a right angle. So look for these little right angle symbols and that's going to tell you altitudes. Altitudes, think about it, when you're thinking about how high something is in altitude, you don't measure its height by measuring slantwise to the ground. You always measure it at a right angle. We measure how tall you are straight down at a right angle to the floor, not slanty over there somewhere. Same thing here. If I want to measure from this vertex to this side, I want to make a right angle to make its altitude, to see how high it is. Same over here. How tall is this triangle? Straight down to that floor. Okay, so altitudes. Make right angles. Okay, come on, buddy, wake up. I'm trying to click my mouse and it's not cooperating. Let's try it this way. Let's see if it likes it here. Come on. Oh, and it appears my computer is frozen.